Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum. My name is Syed Raza Haider, and I am the group leader for this final year project. And along with me is Ali Abdullah assisting me in this project. The project that we did is called Sign Language Detection using Python as our core language and different libraries for the execution of this project. As you can see on my screen that I have VS Code editor, and I use this editor for writing almost every code for the execution of this program. So let's begin. I will demonstrate this project in depth, and we will walk you around every tool that I use and guide you regarding the approach of my project. My file directory for this project includes three main files named create gesture data, train CNN, and model for gesture data. And you can see that there are many different files as well, and I'll explain these as well. And I have a main directory called gesture data, which concludes the training as well as the testing data for the training and testing of our model. Let's begin with our first file named create gesture data, in which I have used the OpenCV library for the manual control of my camera hardware for creating our hand gesture data. As you can see that I have written different functions, namely there's the calculate accumulated average, which takes in two parameters named frame and accumulated weight. And as you can see that I've used OpenCV as the library, and the command that you can see on my screen, cv2.video capture, what it does, it opens up the camera and then the execution of the program happens. I manually created this code which takes in your hand as a gesture, and then it will save this gesture into the gesture file. As you can see that I have saved it using cv2.imwrite, with which is a default function for saving the image into the directory I want. So let's move on to our second file, which is the train convolutional neural networks .py file. So you can see that I've used TensorFlow because TensorFlow is a library that provides us with different the neural networks pre-built and different models, layer optimizers and metrics. So these are the train path and the test path, and I have divided these train batches using the image data generator. And then for a better understanding for my procedure, I have written a function named plot images, and what it does is it plots the images, and I'll show you the execution of this program once I run it. So I've used like three layers, uh, which is a convolutional 2D layer, which is best for the image processing, and the activation method I have used is ReLU for these three layers. And I have used different neural network size. The nodes are 32 as well as 64 and 128, and then I have flattened it so that I can use it for optimizing it and compiling it using the optimizer atom. And I have calculated the validation loss as well as the categorical cross entropy, as you can see through the loss. And the metrics I have used, we can use different metrics as well as the precision, accuracy and several other methods, but I have used accuracy over here. So let's and then in the end, what I've did is I have saved the model using by providing it with the model name and the path. As you can see on the left, where my mouse pointer is pointing, that model.h5 is being saved as I have run the program firstly, but I will execute it again as well. So this is our second file which I have used the code, and the code that you can see over here, it will be better understandable once I run the program and you will see the execution of it. Now moving on to the third file, this is called as a model for gesture data. The model's been trained, as I discussed in the previous sentences, that now it's been saved using this name. And now if I have to predict what output would be given against the image mapped through it, then I will be using this file. As what I'll be doing is I'll be placing my hand gesture on the screen on against the camera, and then what it will does it will be doing is providing the text into the console. We can alter this program. For example, it can be used for several purposes, but this is a very basic program that I have written, and it's a very large scalable project that can be converted into. But for now, it's a very simple project. Now we'll execute this program using our editor, and as you can see through my console window that the models being trained using TensorFlow. Let's begin the execution of the program. So you can see over here that the TensorFlow backend has been activated. For this, an internet connection is required since the data has been going to the server. And let me wait. Yeah. So I'm training the model again. So what it will do is it will be using the TensorFlow backend. It found different images, as you can see that it's showing the plotted images that my training data contains. For example, this is a 4 2 4 5 4 2, and let's close it. And you can see in my console that several the epochs been running, and what epochs does is it is a series of iterations that's been going on into the training data. And I have used 3 epochs because my target for the accuracy was achieved using 3 epochs. But if you are trying to improve your model and making it more better, so you will use several techniques according to your approach. So my approach was basically mental 3 epochs, so that is why I am using this 3 epochs. So let's wait till this epoch finishes off, and then we'll see the output result in the very last. Okay, as you can see that the screen has been appeared the second time because this is showing the test data that we are going to predict it for. But I can, as you can see from the file structure, that there are 2 more files as well as model for gested data and the create gested data. So we'll not be using it as of now, but we can use it for the prediction. But uh, it's for a console understanding. So now you can see that these are the actual labels and this is the predicted values. So the model is not very much accurate, but see there are some values that are corresponding with each other, like the 3 3 or 1 1 1 1, and they are similar as 1 1. So it depends upon the data that how we have stored the data and how much accurate it is, and the layers that we have used. So that's the summary for our project, and this is the result as you can see on my screen where the mouse is pointing. And uh, that's our project. And for this project I would like to thank Professor Dr. Syed Mohammad Khalid Jamal for his contributions and for guiding us for making this project, and for University of Karachi and the chairman Nadeem Mahmood for providing us with these best 4 years and the learning experiences. And that's it. Thanks, and